Put in over here 39.10. 39.10 grams of potassium per mole of potassium. So I put those into my calculator and I see what I get here. Lost my place. Sorry, I don't know how I managed that. There it is. 130. 130 what? Well, yeah, we've got to have the unit or we don't get credit. The atoms canceled out, the moles cancel out, and we're left with grams of potassium. You've got to have that to get your points, all your points for these problems, remember? So in this particular problem, the skill you're demonstrating is that you can convert from mass to number of atoms. And so hopefully you remember then that we're going to get grams to cancel out, and we're going to get moles to cancel out. There we go. And you see that our units will be in atoms of potassium. And what numbers go here? Well, hopefully you remember that 1 mole is 195.1 grams. Did I say potassium? This is platinum. Okay, let's look up platinum here on the periodic table. Right here, atomic number 78, and 195.1 is the atomic mass of platinum. So that's where the 195.1 came in, right here. Of course, 1 mole of potassium is how many atoms of potassium? That's right, 6.02 times 10 to the 23. Make sure you don't forget it. Let's see what we came up with here as an answer. 6.17 times 10 to the 22. But what are we missing in the answer? Atoms of platinum. That's right. So don't forget to be sure you have that in your answer. Moving on to number 9, we're almost down to the last couple of problems here. So for this problem in number 9, this is preparing you for the future. Some of the problems you will work on with moles when you have a chemical reaction, and in that chemical reaction, maybe for some reason in that chemical reaction, it involves calcium and aluminum. And in this reaction, you use 3 atoms of calcium every time you use 2 atoms of aluminum. And so that gives us a mole ratio that allows us to answer the question that, if you started with this much aluminum, how much calcium will you end up with? And of course, I've got a few things missing here, like 1 mole of aluminum is 26.98 grams. That came from the periodic table. Of course, right over here we have 40.08 grams of calcium is 1 mole of calcium. So let's see what cancels out. Grams of aluminum cancel here. Now I've used the mole ratio in such a way that moles of aluminum cancel with moles of aluminum. And right now, if we did 0.213 grams of aluminum divided by 26.98 grams of aluminum times 3 divided by 2, our answer right now would tell us how many moles of calcium we were going to be using. We're going to go on to say how many grams of calcium that is. So remember, this is for a relationship in a specific kind of reaction. And you're going to learn to do this eventually with all manner of different reactions. So let's see what the answer is. And did we leave anything off the answer? No, the units are there. It's to the right number of sig figs. I hope it's right, but you better check all of my work on all of these problems. So moving on to number 10, can you use density? of an element as a conversion factor in a mole problem. So kind of combining that as with a mole problem. And you'll see here that we have cubic centimeters of lead canceling with cubic centimeters of lead. We have grams of lead canceling with grams of lead, so that we come out with the unit moles of lead. So let's go back through here and see what our conversion factors are going to be. Well, our conversion factor right here is that 1 centimeter of lead is 11.34 grams of lead. And here we go, 1 mole of lead is how many grams? Well, once again, there we have to go back to the periodic table. We have to find lead. So lead, atomic number 82, has a mass of 207.12 grams per mole, 207.2. So right here, we'll put 207.2 grams of lead in 1 mole. So you should calculate that as 0.474. Is there anything missing from this answer? Of course, you need to put your unit there, and the unit that hasn't canceled is moles of lead. Moving on to number 11. Is this the last question? It is. So the question here is this. If we have 2 samples of lead, one has 4 times 10 to the 24 atoms of lead, and the other sample has 4 times 10 to the 25 atoms of lead. So we've just got one little number difference up there in our exponent. Well, how much difference will that be in, how much difference will that be in the mass of lead? What's the difference in the mass between these 2 lead samples? So don't forget our question here. Don't forget our question is, what is the difference between these 2? So how do we set this up? Well, one mole of lead is 6.02 times 10 to the 23 atoms. Of course, 1 mole of lead is also 207.2 grams per mole. We looked at that in the last problem. So calculate that. What do you get? You should get something like 1,400 grams of lead. Now, if we just make one change in that coefficient, one change right here, change that to a 5, how much difference does that make in the mass? Well, let's put in our numbers here. And here. So we've got these 2 problems set up the same. What's the mass that we're looking at here for this many atoms? Did you get it calculated? There it is. 14,000. 14,000 compared to 1,400. That's the difference of one little exponent up there in the problem. So what's the answer to our problem? Well, the answer to our problem is 14,000 minus 1,400. And of course, you probably can do that in your head, but let's pull up the calculator here. 14,000 minus 1,400 equals 12,600. Let's see, there we go. 12,600. That's the difference in our measurement. But remember here, we can't go past this least significant number, so we can't really go past the 12. So we're going to look at this, and we're going to round it up to a 3, so it looks like a difference between, there's a difference of 13,000. What's our unit here? Our unit is in grams. A difference of 13,000 grams. Of course, that's about 13 kilograms, and that's a difference of 2.2 pounds per kilogram. So what's 13 times 2.2? Come on, calculator, pop up here. 13 times 2.2. So that's about 30 pounds difference between that little exponent of lead up there, 30 pounds different. Now, if that had been a difference between 25 and 26, maybe that would have been 300 pounds different. Yeah, still just a difference of one exponent, but it really depends a lot on what those two exponents are. Okay, well, you finished that. You are ready for the test as long as you know how to do all of those problems.